So we are doing a question for May 2019. Those who are joining May 2019. Question number 1, I think number 1B. The question is about application of linear equations, and one of the applications of linear equations is how to compute salaries and wages. So we say one of the applications is computation of wages and salary. Now you have said we shall use this normal equation y is equal to mx plus c to determine the total earnings. Yeah, this one will help us to determine the total earnings. And in this aspect, you can see that our y is our total earnings. Then x, our x is our commission. So x is our commission, which depends on m. M is the number of units sold. So m represents number of units sold, and then our c is our fixed item, which is our basic salary. So we can come up with the equation. We say, so we're in 2019 February, when the total earnings is 60,000, we can say that it depends on the basic salary. So what's our basic salary? So we don't know the basic salary. Let us say our basic salary is C. We don't know our basic salary, but we know our commission. Now our commission depends on the number of the items sold. Now remember, this one represents our X. So if it is 60,000 and also 100 units, which depends on M, which depends on M. Now, if it is 70,000, we don't know our basic salary, but we know if it was 250 units, which is our X, will depend on M. So it will depend on M. So when you have those two equations, then you can find the value of M and C. You can find the value of M and C. You can find the value of M and C. Let us find the value of M and C. You can see, do we eliminate elimination method? So we eliminate C. How do we eliminate C? By lessing the two items. So 60 minus 70. So 60 minus 70. Ngapi? 60 minus 70. 60 minus 70 minus 10,000. So that will be equal to minus 10,000. 0 plus. So C minus N is 0. Then 100 minus 250 gives minus 150. So find the value of M. Now M will be equal to minus 10,000 divided by the minus 150. What will be the value of M? Yes, 10,000. So it will be equal to 66. So itakuwa ni Kenya shilling. So 1 unit sold at which amount? So 1 unit sold at 66. 66 2/3 per unit. So that's the value of M. So the maana mtu ametype hapa. That one is correct. That one is correct. That is correct. We go to number. Let's find C now. Now we choose one of the equation, 1 or 2. This one is equation 1. This one is equation 1, and this one is equation 2. So choose one of it. So I'll go with equation 1. So 60,000 is equal to C plus 100. Then M we replace M with 66 2/3. So what's the value of C? Now C will be equal to 60,000 minus 100, 66 2/3. So what is the value of C? What is the value of C? So 60,000 minus 100, 66 2/3. So what are you getting? So mimi napata 53,000 333, 1 over 3. So meaning our equation is equals to 53, 1 over 3 plus 66, 2 over 3 x. So this is our equation, which represents the equation which you can use to get the total salaries. Now I want to ambia number B. So part A, the answer to part A, what was the requirement for part A? So part A, I'm going to calculate the fixed salary. Now fixed salary is Kenya shillings 53, 1 over 3. That's part A. This part A, you are required to compute the fixed salary. Part A. Part B, commission per unit sold. So commission per unit, number B, commission per unit. Commission per unit itakuwa ngapi? No, commission per unit is Kenya shillings 66, 2 over 3 per unit. So commission per unit is Kenya shillings, that one. It is Kenya shillings, that one. Alafu ya mwisho alikuwa anasema nini? Ya mwisho alikuwa anasema total earnings for the month of April. Total earnings for the month of April. So April, so units for April. For April, the question is 400 units. So it is 400 units. So it is 400 units. So how do we compute it? How do we compute what we call the total earnings for that month? So we say y is equals to 53, 1 over 3 plus 66, 2 over 3 x. Our x, remember our x is the number of units. X is the number of units, which our x in this case, x is 400. So x is 400. So give me the answer. So 53 plus 66, 2 over 3 multiplied by 400. So it is Kenya shillings. So total earnings for 400 units, itakuwa Kenya shillings. Kenya shillings 80,000. Kenya shillings 80,000. So that's how you are supposed to do that question. That is how you are supposed to do that question. So do you have any question concerning that one? So mlipata hivyo, those who did that question, did you get the same item?
Yes.
Okay, so we can move on. We can move on to something else now. Another topic. So let us introduce another topic. And the topic is matrix. So the topic is matrix. So matrices is our topic. Let us start by defining what is a matrix. Let us start by defining what is a matrix. So what is a matrix? Those who managed to join the other class from the Telegram. So what is a matrix? Now when we talk about a matrix, we say a matrix refers to the rectangular arrangement of numbers. So matrices we say refers to rectangular arrangement of numbers. So we talk about when we talk about matrix, so matrix refers to the rectangular arrangement of numbers which are enclosed within a bracket. So which are enclosed within a bracket. So which are enclosed within a bracket. That is a good definition of the word matrix. So in an exam, if you find such kind of a question required to define what's a matrix, then you shall say that a matrix refers to rectangular arrangement of numbers which are enclosed within a bracket. That one is okay. That one is okay. Now we can say the numbers are known as elements. The numbers are known as the elements. You see, the numbers are known as the elements. So the numbers which are inside which are enclosed inside are known as the elements. Now vertical arrangement of is known as vertical arrangement of column. Vertical arrangement of numbers called column. Yes. So tunasema vertical arrangement of numbers is called columns. So vertical arrangement of numbers is called columns, while we can say horizontal arrangement is known as the rows. While horizontal arrangement is called a row. Is called a row. Is called a row. So that's a definition of the word matrix. So when we talk about any rectangular arrangement of numbers, which is enclosed in a particular something, rectangle, then that one is what we call a matrix. So I think that one is okay. Okay, nice. Let us move on. Before we go to type of matrix, let me see if we can so we have said matrix is defined as a rectangular arrays of numbers which are called elements. and it is represented by writing down the elements and enclosing it in a bracket. That one is okay. We can give an example, i.e., 2 by 2 matrix. We can give 2 by 2 matrix to 2, 3, 4, 5. Another can give 3 by 3 matrix, 3, 5, 6, 7, 8, 2, 6, 7. So the number inside the brackets, so the numbers inside the brackets are called the elements, while the numbers which are enclosed, so when you enclose those numbers using a bracket, then those items will be known as the matrix. So then those items will be known as the matrix. Okay, type of matrices. Type of matrices. So I don't want to write so many things. Type of matrices, number 1, square matrix. Square matrix. Those are square matrix, some are square matrices. Now, this is a matrix, refers to a matrix where the number of row and column are equal. The number of row and column are equal. So that matrix where the number of row and column are equal is what we call a square matrix. And a good example is 2 by 2, i.e., 2 by 2 matrix. As you can see, the number of row and the number of column are the same. Or we can also give 3 by 3 matrix. Or you can also give 4 by 4. So the number of matrix, so the number of column equals to the number of columns equals to the number of row. But to find this kind of a matrix, when you go and find this kind of a matrix, look at this one, 2 by 3. Now this one is not a square matrix. That one is not a square matrix. Reason why? Why is it not a square matrix? Because the number of column and row are not equal. The number of row and column are not equal. But where we have a square matrix, so 2 by 2, 3 by 3, 4 by 4, then that one automatically becomes a square matrix. Okay. Diagonal matrix. Diagonal matrix. Diagonal matrix. So what's a diagonal matrix? So change this one to matrix, Papa. Square matrix. The diagonal matrix. So it is a square matrix. It is a square matrix. It is a square matrix having all elements, except, so having all the elements except the main diagonal, except the main diagonal, except the, so as it's a square matrix having all the elements except the main diagonal. And we can say n and those elements are consisting consisting of numbers. Numbers other than one. Other than one as diagonal matrix. Let's give an example, i.e. an example. So 3, 0, 0, 0, 4, 0, 0, 0, 5. Now, our main element, you're here. So our main element is 3, 4, and 3, 4, and 3, 4, and 5. Now, when all the other numbers, so it's a square matrix where all elements except the main diagonal. So it's a square matrix having all the elements except the main. So it's a square matrix having all the elements except the main diagonal, and those elements consisting of numbers other than one as the main diagonal. So consist of numbers other than one as the main diagonal. Now, a good example in here. So our main diagonal has numbers, so 3, 4, 5, but the other elements, so can get 0, 0, 0, 0, 0. So apart from the main, now apart from the main diagonal, remember the main diagonal you here, remember the main diagonal, if you want to draw it. That is the main diagonal. So the main diagonal has elements, but the other items, the elements are equal to 0. The other elements are equal to 0. So that's what we call the diagonal matrix. It's a matrix where the elements below the diagonal are shown without the one above the diagonal and vice versa. That one is okay. That's a diagonal, but we use this one. So it's a square matrix. So it must be a square matrix having all elements, except the main diagonal and those elements consisting of numbers other than one as the diagonal matrix. So that one is okay. Next is a unit matrix. So unit matrix, unit matrix. Now for unit matrix, the main diagonals element equals to 1. So unit matrix. Now unit matrix. So it must also be a square matrix, but the element in the main diagonal is equal to 1. So we say it's a square matrix So it is a square matrix with every element 0, with every element 0, except the mid diagonal. The mid diagonal. And this and this and this consisting entries of 1, and this consisting entirely of 1. So that's what we call of 1. So that's what we call the unit matrix. That's what we call the unit matrix. So you can give an example. So the main diagonal is always equal to 1. So let us give an example. And the other elements are equal to 0. So other elements 0, but the main diagonal is equal to 1. So 1, 0, 0, 0, 1, 0, 0, 0, 1. So that's a good example, i.e. So that's a good example. So that's a good example of a unit matrix. So that is a good example of a unit matrix. You can also give for 2 by 2 matrix. Now 2 by 2 matrix, the 1, 0, 0, 1. 1, 0, 0, 1. So 1, 0, 0, 1. So that one is okay. That is okay. Sometimes it's called the identity matrix. So you can also call it the identity matrix. So sometimes you can call it the identity matrix. Now let's go to the next one. Next one is null matrix. Null or zero matrix. Null or zero matrix. So null or zero matrix. So null or zero matrix, and we say a null matrix equal to 0. So a null matrix equal to 0. And every element in the matrix is 0. Every element in the matrix is 0. So every element in the matrix is 0. I.e., you can give an example, i.e. 0, 0, 0, 0, or 0, 0, 0, 0, 0, 0. So those two are example of matrix, which are null matrix. Okay, go to another one. Scalar matrix. Scalar matrix refers to a diagonal matrix. Refers to diagonal matrix. A matrix whose all diagonal elements are equal. Whose all diagonal matrix elements are equal. So refers to diagonal matrix. Refers to diagonal matrix whose all the diagonal elements are equal. For example, i.e. 2, 0, 0, 2. So 2 and 2 are the same element in the diagonal matrix, so they are considered scalar matrix, or 3, 0, 0, 0, 3, 0, 0, 0, 3. So all the items inside the diagonal are the same. Let's talk about transpose. The transpose of a matrix. the transpose of a matrix we say the matrix obtained from any given matrix so the matrix obtained from any given matrix by interchanging its row by interchanging its row and columns. So this is a form of matrix. So this is a form of matrix that is obtained from any given matrix. So this is a matrix obtained from any given matrix by interchanging its row and column. Example, i.e., you have this matrix A as follows: 2, 4, minus 1, 5, 0, 2. Now, for us, if you want to obtain the transpose, this is how you show the transpose A and something hapo juu. So that is the symbol for transpose. Now we interchange. Now, so 2, 4, minus 1. So at this moment inaenda hivi. Now we interchange it, iteremke chini. So itakuwa ni 2, 4, minus 1. Same applies to 502 inaenda hivi. So we interchange, iteremke chini, itakuwa ni 502. Now that one is a transpose. So that one forms 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 a transpose. Okay. Inverse matrix. Inverse matrix. Inverse matrix, and we say the inverse matrix is equivalent to reciprocal. Reciprocal. Supposed to be reciprocal number, and it's already defined, and it is already defined. It is already defined in relation to something else, and it is always defined in relation to something else. To something. It is always defined in relation to something else. Now, i.e., the i.e. We can find an inverse of a particular something. Let us find an inverse of a number. Inverse of a number. We shall do 2 by 2 matrix first. So 2 by 2 matrix. So let us do for 5, 9, 5, 9. Let us do find 5, 5, 9, 6 minus 2. How do we find that inverse? How do we find inverse of that item? Now, the inverse will be given as follows. Now, this is how you find the inverse. Let us see how to find the inverse. The first thing you find is the determinant. You find the determinant. Determinant. And to find the determinant, do you know how to find the determinant? Yes. How do you find the major diagonal? So you take the major diagonal less minor diagonal. So let me show you how. Let me show you how. Someone the one type of 64. But let me explain something before you do that question. So we have A. We have A, B, C, and D. So we have A, B, so now you have A, B, C, and D. So how do we find the determinant from that equation, Apple? How do we find the determinant? So this is how you find the determinant. The determinant will be equal to, so the main matrix hiyo itakuwa ni A times B minus, then the minor hiyo B times C. So B times C. So B times tuanze. Hii yetu hapa. Tunajua ni 5. times minus 2 minus 9 times 6. Inakuja ngapi? This is equal to negative 64. Now, and then we interchange the item. So the inverse. Now, if this one was matrix, let's give this one as matrix A. Now, if this was matrix A, if that one was matrix A, if that one was matrix A, then for you to get the inverse of that matrix, the inverse is given in that format. So itakuwa ni 1 over minus 64. Then we open the bracket. Then we open the bracket, then we interchange. Now, this we interchange the items in the main diagonal. So we interchange them. So 5 and minus 2, interchange them, itakuwa ni minus 2 and 5. Then we change the signs of the minor diagonal. So 6, it is positive, so we change the sign to be minus 6. Then 9, we change the sign to be minus 9. So we just change the signs of the main diagonal, of the minor diagonal, sorry. Okay, that one is fine. So that's an inverse. That's how you find the inverse of that number. So that's how you find the inverse of that number. That's all about it. So that is all about it. We can also talk about the singleton or the scalar matrix. We call it the singleton. So singleton matrix. Singleton matrix, and we say this is a matrix with only one element. This is a matrix with only one element, i.e. inakaa hivyo. This is a matrix with only one element. We can also talk about column vector matrix. Column vector matrix. Column vector matrix, and you can say it is a matrix with only one column. It is a matrix with only one column. This one represents a matrix with only one column, but more than one row. But more than one row. But more than one row. i.e. 2, 6, 7. Now the column kwenda hivi. So column inamaanisha hivi. Column ni kwenda hivi. Sivyo? So ukienda hivyo column ni moja, but ukiteremka chini ni row. So this one is column. Ukiteremka chini ni row. So ukienda side hii, so we have only, so this is a matrix with only one column. One column, but with the many row. Then the opposite, we have the other one, the opposite of it. The opposite, we call it the row vector matrix. Row vector matrix. Row vector matrix. row vector matrix, and you can say it's a matrix with one row, but more than one column. It is a matrix with only one row, but many columns. Columns. So i.e. 2, 6, 7. 2, 6, 7. 2, 6, 7. 2, 6, 7. 2, 6, 7. So that's a good example of that one. So that's a good example of that one. We can look at some of okay, we are about to tunaenda vizuri, sio mbaya. I think the progress is okay. So type of matrix tumemaliza, meaning and type of matrix tumemaliza. I think we can talk about operations of matrices. Operations of matrices. Operations of matrices. Number one, additions, and we'll give you just an example. So remember, we are just giving examples. They are just addition example. So for example, we have this item 2604 plus 1, 2, 3, 4. So what will be the answer? How do we add it? How do we add it? So now add it. So 2 plus 1, the one is 2 plus 1, then 0 plus 2, 0 plus 2, and then 6 plus 3, 6 plus 3, then 4 plus 4. So that your final answer, will be equal to 3, 9, 2, 8. Iko sawa? Ndio haina mambo. So that's addition. So hiyo tusindi hapo. Number 2, subtraction. Number 2, subtraction. So for example, 2064 plus 1332. So how do we do that one? So unasema itakuwa ni 2 minus 1, 2 minus 1, 0 minus 3, 6 minus 3, 6 minus 3, and then 4 minus 2. So hii inafanywa hivyo. Then you get the final answer. So 2 minus 1 is 1, minus 3, 3, and 2. That's how you find that one. So if tunasonga haraka, that's how we do subtraction. Then tunaenda ya mwisho. Ati hapo kwa subtraction ni 2 minus 1 na 0 minus 3, and then 6 minus 3 na 4 minus 2. So hiyo tunaonesha hizo ni vitu za kawaida. Then we go to multiplication. So kwa multiplication ndio maybe we can talk about it. Multiplication. Multiplication. So hapa kwa multiplication ndio maybe we can talk about it. And maybe kwa division. Multiplication and division. So we start with the multiplication first. We start with multiplication first. Sasa with the multiplication down. Exit. So a matrix can only be multiplied if the number of columns in the first matrix are equal to the number of rows in the second matrix. That is the one. That is the first rule you need to know. We say a matrix can only be multiplied. A matrix can only be multiplied if. So a matrix can only be multiplied if the number of the column in the first matrix, the number of column in the first matrix, matrix is equal to the number of row in the second matrix. Tunasema a matrix can only be multiplied if the number of columns in the first matrix are equal to the number of rows in the second matrix. So if this is compatible, if this is compatible, so if now, sorry, in this case, the matrix is said to be compatible. The matrix is said to be compatible. So in this case, the matrix is said to be compatible. Compatible. So in this case, the matrix is said to be compatible. Now let us see. i.e. 4, 2. We have this one 4, 2, 3, 1 times 4, 3, 2, 1. 4, 3, 2, 1. Now can you multiply these two matrices? Can we multiply these two items? The answer is yes. Reason why? Because the number of columns here is the same as the number of row. So the number, so huku ni 2. So our column is 2, and our row is also 2. So in the first matrix, the column is 2. So in our first matrix, the column is 2. Ukienda kwa the second matrix, ukiteremka chini, the number of rows is also 2. So meaning this one is possible to compute. So this one is possible to compute. Let us now try. How do we compute it? We say itakuwa ni 4 times 4. Hiyo ni ya kwanza. 4 times 4 plus. So we are saying under the first column, 2 times 2. 2 times 2. Hiyo ni ya kwanza, tumemaliza hivyo. So unaenda hivi. So kwa the first one unaenda hivi, kwa ya pili unateremka. Kwa ya kwanza unaenda hivi, kwa ya pili unateremka. So twende kwa ya pili. So 3, so ya chini yake hapa 3 times 4 itakuwa ni 3 times 4 plus 1 times 2. 1 times 2. Ndio tumemalizana hivyo. So we can go to the last one side here. 4, this one 4. Now tunasaka kwa pili 4 times 3. 4 times 3 plus 2 times 1. 2 times 1. Then ya mwisho itakuwa ni 3 times 3. 3 times 3 plus 3 times 3 plus 1 times 1. So what will be the final product? Column ni hii yenye inaenda hivi. Ukiwa na equation yako hapa. This one is the column. This one. Inaenda hivyo. Then yenye inateremka chini hivi. Teremka chini. That one is the row. So that one is the row. The other one is the column. So ukienda hivi column teremka chini. Ni row. Sasa tunasema for you to do this multiplication, the number of column must be equal to the number of column in the first row. This one, ukiangalia hapa, we have 2 of them. Must be the same as the number of column teremka chini hapa. So ni 2. So zote ni 2, ni 2, 2. So zote ni 2 and 2. So tunasema it is possible for you to calculate them. So that's what tunasema, that one is possible for you to compute them. So that one is possible for you to compute them. Now, let us add them. 4 times 16. So 16 plus 4 nakupatia 20. 4 times 3 ni 12 plus 2 times 14. 3 times 4 ni 12 plus 2 also 14. Then 9 plus 1, which is 10. So that is how you are supposed to find that item. So that one is how you're supposed to do that item. Now, let me give you this one. Do for me. Do for me. Another one. We have 432. 432. 043. 043. Multiply with 421. 421. 9612. 9612. So niwapatia how many minutes? So let me give you 2 minutes. Let me give you 2 minutes. Let me give you 2 minutes. Now, how do you compute it? Geoffrey? Geoffrey, how do you compute this one? Yes, that one is impossible. So impossible. Reason why? Now let us see why is it impossible. Now we can see the first one. So the first one we have to the first matrix, but the second matrix column. Sorry, let's start with the column. Column is 2, and the second matrix, the row is 3. Now this one, they are not equal. They are not equal. So they are not equal, and therefore they are not compatible. So they are not equal. So we can say they are not compatible. 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 Now let's go to the next one. Let's go to the next one. The next one is about subtraction. The next one is about subtraction. So tulikuwa nasemaje? Kwa nasema tunaenda kwa subtraction. Subtraction.
Inverse.
Inverse. Or division. So it's supposed to be division.
Yes.
So division. Now, so also called, you can also call it the inverse. Also call it the inverse. So you can say the following steps are followed when getting the inverse of 2 by 2. You say the following steps are followed. When getting inverse of 2 by 2. So the following steps are followed when determining the inverse of 2 by 2. So step number 1. So step 1, compute the determinant. Number B, reciprocate the determinant. Reciprocate the determinant. Reciprocate the determinant. Step number 3, interchange the major diagonal element. Number 4, change the signs of the minor diagonal. Change the signs of minor diagonal. So we don't need to give an example because it's got to but okay, let's just keep it. I.e., let's assume we have this form of so we have 4, 2, 3, 3. So find the inverse matrix. So should have a division. This one is I.E. matrix A. So step number 1. Step number 1, we compute determinant. Step number 1, we compute determinant. Tunajua ni major diagonal minus minor diagonal. So we say ni 4 times 3, 3 times 2. So inakuwa ngapi? So 4 times 3 minus 3 times 2. Napata 6. This is step 1. Step 2, we compute the reciprocal of the determinant. So the reciprocal of the determinant will be equal to 1/6. So that is the reciprocal of the determinant. Then step number 3, we interchange the major diagonals. Step 6, we interchange the major diagonals. So major diagonals will 4 and 3. We interchange them equal to 3 and 4. So we interchange the major diagonals. Then step number 4, we change the signs of the minor. Now the signs, so 2 ni positive. Kama 2 ni positive, we change the sign, itakuwa ni minus. 3 ni positive, we change the sign, itakuwa ni minus 3. That's all. That is how we get the inverse of 2 by 2. We shall do 3 by 3 later. So 3 by 3 is not common, but tutaifanya. It's not common in our past paper. So mostly in our past paper, it's not common, but tutaifanya later to be the last item after we finish this topic. So I don't want to talk about it so much. Application of matrices. Application of matrices. Application of matrices number 1. Used in solving simultaneous equation. Used in solving simultaneous equation. Number 2. Used to determine demand and supply. Used to determine demand and supply. So used to determine demand and supply. Number 2. Number 3. CVP analysis. Number 4. Markov analysis. Number 5. Leontief analysis. Leontief analysis, or we'll call it input-output analysis. Input and output analysis. Input and output analysis. So input and output analysis. So we start with the first one, simultaneous equation. So we shall start with the first one, simultaneous equation. So number 1, we can do that one, then the rest. So another time. So we need to do all this. We need to do all this. So we shall start with the first one. Solving simultaneous equation. Let's go to this first paper. It's going to find side May 2019. Because that one they said you use matrix. So let us go to number one, simultaneous equation. Simultaneous equation number one. So simultaneous equation. Let's go to our past paper. Let's go to our past paper and we start with the question for May 2016. So May 2016, give me the figures. May 2016. May 2016, question number 1B. May 2016, question number 1B. Mulipataje? Mko mmefanya May 2016?
Yes.
For example, let's talk about an individual or a teenager. So an individual. Aya, mulipata ni phase of figures. The phase of equations. Okay, and a certain audit firm has 2 employees. Let me share with you. So a certain audit firm has 2 categories of employees, the auditor and assistant auditor. So we say, let auditor be X and assistant auditor be Y. So we can give that an assumption. So a certain audit firm has 2 categories of employees. We have the auditor and the assistant auditor. The total monthly salary of 1 auditor and 5 employees and 5 assistants is, so tunasema 1 auditor, so X. So X plus 5Y is equals to 456,755. 456,755. 456,755. And then, whereas the total monthly salary of 3 auditors, 3X plus 9Y is equals to 985. 985,005. 985,005. So the firm has a total of 6 auditors. So the firm has a total of 6 auditors and 14 assistants. And 14 assistants. So the employees contribute 12% of their salaries towards the circle. That one's okay. Required the monthly salaries of an auditor and assistant auditor using the matrix algebra. Let us now do it together. So we are going to use the matrix method. We're going to use the matrix method. And that will be the end of our first application. So we shall do others. So we shall say, let us do using matrix. So tutasema, so let us write it in form of a matrix. So itakuwa 1. We can say what? I'm trying kufikia venye tunaweza. So we want to find the value of X and the value of Y. You can say now, okay. So this is our equation: X plus 5Y is equal to 456,755. Then 3X plus 9Y is equal to 985,005. So we can say 1, 5, 3, 9 as our matrix is equals to xy. When we multiply with xy, it must give us the figures 456, 755, 985, 005. Is that one okay? Now, let's find xy. Xy will be equal to, now we need to divide it every side by this figure. So we divide this side by this matrix and also the other side. So if you divide it with this matrix on this side, itaisha. So that matrix itaisha. No, but if you divide it with the other side, itakuwa ni 1, 5, 3, 9, but it must be an inverse because we divide. So on this side, so to divide this matrix on this side, the same with the other side. So this side itakata, but the other side itakuwa inverse, which you multiply with 456, 755, 985, 005. Then ukishafanya hivyo, now this one represents an inverse. So hii hapa 1539 minus represent an inverse. Now let's find that inverse. How do you find that inverse? Itakuwa ni 1 times 9 plus a determinant. We start with the determinant. Itakuwa ni 1 times 9 minus 1 times 9 and then 5 times 3. Mnapata ko ngapi? Mnapata ko ngapi? So 1 times 9 minus 5 times 3. Mnapata ko minus 6?
Yes, -6.
So let us find the inverse now. Itakuwa ni 1 over 1 minus 6. We open. So we change the main diagonal, 1 and 9. Itakuwa ni 9, 1. Then we change the signs of the other one. So itakuwa ni minus 3, minus 5. Is that one correct? So xy will be equal to what? It will be equal to minus 1 over 6, 9 minus 5, minus 3, 1. We need to multiply it with 456, 755, 985, 005. So let's start with x. What will be the value of x? The value of x itakuwaje? Now the value of x will be equal to minus 1 over 6. Then we open the bracket at the first one. So itakuwa ni 9 times 456. So itakuwa ni 9 times 456, 755 plus minus 5 times 985, 005. So what will be the value of x? Minus 1 over 6 times. Let us do it. So 9 times 456, 755 plus minus 5 times 985, 005. So mi napata minus 814 to 30. So what will be the value of x? So answer times minus 1 over 3. Minus 1 over 6. So 135, 705. You repeat the same for y. Minus 1 over 6. So itakuwa ni minus 3 times 456, 755 plus 1 times 985, 005. So what will be the value of y? Minus 1 over 6 times. Itakuwa ni minus 3
Negative 385 to 60.
Mute. Itakuwa minus 1/6 times 382 to 50. So mnapata 63 708 2/3. Are you getting that one? Yes.
No.
Napata ngapi?
64 to 10.
Oh, this is supposed to be to 60. (64 to 10). So that will mark the end of number 1, simultaneous equation. That will mark the end of the first one, simultaneous equation. 4 others to go. 4 others to go. 4 others to go. So we shall meet the next time. We continue with the next items. So at that point, do you have any questions? Assignment. So I'm checking the now correct the assignment. So make sure umenitumia pia zile za kwanza. So December 2010, question number 1. If you don't have that question, utaniambia nikutumie. December 2009, not 2010. December 2009. Question number 1A. You can also do December 2011, question 1A. December 2011, question number 1A. December 2011, question number 1, not 1A. A is 1A, that one is correct. May 2016, 1B tumefanya. May 2019, 1B. May 2019, 1B. May 2019. So we shall start from demand and supply. We shall start from demand and supply. We shall start from demand and supply. Next class will be we shall start from demand and supply. Any question at that point? So nani Rosie anasema ati screenshot is not allowed. Where? I'm not getting.
So it is impossible for one to screenshot because the Zoom does not allow us to screenshot.
Yeah, we'll try to screenshot again. Maybe you need to change the settings. So unasema screenshot inakataa. Someone else who have tried to screenshot ikakataa. The rest. Brenda ushajaribu screenshot.
Yeah, tunakubali.
So Roslyn, you shall check again when kama itakubali on your side. You shall try, but just make sure you do the assignment and then you just take a pic and then ukipiga picha unanitumia. So you just do it. So you have those 3. When you want hizo past paper, you shall text me. I'll send you the past paper. When you want ya 2009, ya August 2009, ya December 2011. So that's all about for today. Tomorrow we shall have financial accounting, and remember tomorrow we shall have a very long way. So we shall do something very, very long. So be ready for that one. So itakuwa ni purely compute values. So make sure you join. So, but with that one, I want to wish you well until tomorrow. So that one for now is a goodbye. So in the evening, we don't have a class today. So back tomorrow, financial accounting. So for now, just do the revision for what we have been doing, and make sure you follow on the videos on the Telegram, because we have a lot of videos there for other topics. So because maybe time time that to shika. So, but as you keep on doing reading other topics will be the best for you. So, but that one, let us meet to the day after tomorrow. But tomorrow is a financial accounting purely.